um, from last time. So you guys had 2 homework assignments, right, that you should have kind of gotten started on. So we'll start by taking questions from those if you have anything. Bianca?
So homework 1, and then like the ABC part. My question is, it says like use your graphing calculator to solve or whatever. You first have to solve it, and then put the
Nope, you just type in the equations. They have to be in y equals form.
Okay, so like you just have to cancel out like the x.
Well, like for A, for example, is ready to start.
Yeah.
So you just have to do like some rearranging.
Okay, can we do
Sure. So can we stop talking, please? Yes, Ben. No. No. We have a lot of stuff still to do here in this chapter. So this one is a little bit longer than the previous. So for B, to put this into our calculator, we'd have to start by getting the equations into slope-intercept form. So for the first equation, I need to subtract the 2x over and then divide by -1. And then for the second equation, I have to add the 6x over and divide by a +3. Yes. But then I divided by -1, right? So yes, it would become negative when I subtract it over, but then I divided by -1 to get it there. Yep. And that's why the 4 became negative. So far, so good, Bianca? Hallie? We haven't done it yet. Okay. So this is something I could now type into my calculator, but I don't need to. I can look at this and tell what's going to happen. What can we tell by looking at this? I notice that the slopes are the same, but the y-intercepts are different. So there's no solution here. Now you could type this into your calculator. What would the picture look like if there's no solution? The 2 lines will be parallel, so they'll never intersect. Okay with that, Bianca? Yeah, so I didn't actually do this in my calculator because I didn't need to. I mean, you could have, but there's no intersection to find. Mm-hmm. Anybody else with questions from the last 2 homework assignments? Happy to do more. Okay. Fair enough. I just want to remind you guys that we should be, even though homeworks aren't due until Sunday, you definitely should be starting these before Sunday. Because if there's issues on things, it's nice to be able to ask questions before you actually have to have them completed. Ben?
Homework 3, can we do number 8?
Homework 3, number 8? Sure.
Thank you.
One thing here with homework 3 that worth pointing out to you, not every answer is nice. So number 7 and 8 are both kind of crummy decimals. So just in case you're doing things and you wanted to check. Let's see, where is it? I have it in here. The solution for 7 is 181 over 19, comma, negative 171 over 19. And similarly for number 8, this is also a yucky fraction. So 59 over 57, comma, 52 over 57. We'll do 8 still, but I figured I would let you know that the answers are pretty gross on those two ones. So if you're getting a gross answer and you're like, that can't be right, well, maybe it was. All right. So Ben, when you look at 8, probably the thing that freaks you out the most is the fraction going on here, right? So would this be a big deal if we got rid of the fractions? Right, would make the problem much easier to deal with. So let's do that. So what can I do to this equation to get rid of the fractions? Yeah. Multiply it by 7. Right? If I multiply both sides of this equation by the number 7, I would get negative 5 minus 11x, 7y. Is that okay? Now, if I'm going to solve this system by elimination, which is what the directions ask me to do, I'm going to want to rearrange this so that like the x's, the y's are on one side and the constants on the other. Everything lines up vertically. So I'm going to subtract 7y over and then add 5 over. And in the second equation, I'm going to subtract 5x over. And that's going to be the system that I'm going to try to solve. So I did a little bit of work there to get rid of the fractions initially, because that's going to pay dividends later on, right? Nobody wants to carry those fractions through the whole problem if they don't have to. And we don't. And then we want to make sure we've rearranged them so that the x's, y's, and equal sign and constant all lines up like we have here. So now we need to pick a variable to eliminate. If I look at the x's and the y's, they're about the same, really. There's no easier route. Personally, I'm going to pick to eliminate the y's because the numbers are a little bit smaller than eliminating the x's. And if the numbers are a little bit smaller, it makes the arithmetic a little less tedious for me. So that's what I'm going to choose to do. Right now, if I add these two equations, the y's aren't going to cancel because one is a negative 7, the other is a positive 2. But the number that both 7 and 2 go into is 14. So that's what I'm going to turn the y's into. To do that, I'm going to have to multiply equation A by 2 and multiply equation B by 7. So when I multiply all of equation A by the number 2, 11 times 2 is 22. 7 times 2 is 14. And 5 times 2 is 10. And when I multiply all of equation B by 7, 5 times 7 is 35. 2 times 7 is 14. And 7 times 7 is 49. And then I'll add down. So that gives me negative 57x, negative 14y and positive 14y cancel out, and 10 plus 49 is 59. And then if I divide by negative 57, I get negative 59 over 57. So far, so good. So that's half of my solution. I still have to solve for y. To do that, I'm going to take my value for x and plug it back up into somewhere here. I'm going to choose to plug it in right here. But any place where I have two variables would be okay. So that tells me 2y is equal to 7 plus 5 times, and then I have 59 over 57. So now I just need to solve for y. I'm going to start by simplifying the right-hand side and combining those like terms. So to multiply fractions, I just multiply the tops and bottoms together. So I think about 5 as the fraction, 5 over 1. 5 times 59 is 295. And 1 times 57 is 57. And then I need to make a common denominator so I can combine the 7 and the 57. To do that, I'll multiply the top and bottom of 7 by 57. So that'll give me 399 over 57 minus 295 over 57. And when I subtract those, 399 minus 295 is 104. And then I just need to divide both sides by 2y. But because I have a fraction here, rather than thinking about it as dividing by 2y, I'm going to think about multiplying by the reciprocal. So multiplying by 1/2. That just makes the life a little bit easier. So I notice the 2 goes into the 104, leaving me with 52 over 57. So our final answer then, again, is this negative 59 over 57, comma 52 over 57.
Right, so you have 2y equals 7 by 295 over 57. How did you get that? And then someone with 399.
So 5 times 59 over 57 is 295 over 57. And then the 7, if I multiply the top and bottom by 7 over 1, by 57 over 57, that's the 399 over 57. It's just me making a common denominator so I can combine those two fractions. Okay with that? Yeah, you're welcome, Ben. Okay. Last call from last night's homeworks. Doesn't mean you can't ask about them again later, but just means that we're not going to talk about any more of them today. Anybody want to squeeze one more in? Bianca? Homework 1, number 5. Actually, I think I have that already on this page. Okay. So to graph these, so the first equation is already in slope-intercept form, so I don't need to really worry about that one. The second equation I'm going to rewrite to put it in slope-intercept form, so I'll subtract 3x from both sides and then divide by -1. That gives me y equals 3x plus 6. And then I will make a xy table for each of the two equations. So the first equation, maybe I'll pick a value for x. Maybe I'll say x is 0. When I plug 0 in for x, I get -2 times 0, which is 0, plus 1, which is 1. So there's my y. And then maybe I'll pick another value for x. Maybe I'll pick 3. Doesn't really matter. -2 times 3 is -6. And then plus 1 is -5. And then I'll do similar thing for the other So again, maybe I'll pick 0 for x. 3 times 0 is 0, plus 6. And then maybe I'll pick negative 2. 3 times negative 2 is negative 6, plus 6 is 0. And now I'll just go ahead and plot. So I have 0, 6, negative 2, 0, and looks something like that. And I have 0, 1, and 3, negative 5. It's going to look something like that. So it appears my intersection is here. That looks like it's the point negative 1, 3. And that's it. If you're doing this on a sheet of paper, I would suggest using like graph paper and a straight edge to really have this come out well. But on the tablet, you know, we do the best we can. You're welcome. But I think that's the answer, right? Satisfies the first one. And then says, yeah, so that's the correct answer. Okay. Cool. All right, so today we're going to be talking about solving 3-variable systems. So here we're going to give an example. And we'll do this example both by substitution and by elimination. And from there on out, I'll let you guys pick whichever method you feel like you want to do. I won't, for 3-variable systems, I won't require you to do either substitution or elimination. I'll just let you choose. Because you'll see that the problems are kind of lengthy enough to where all you really need to do is get good at one of them. Is they're complicated enough that I don't need you to be good at both ways of doing it. Let me write down an example. Solution, and the next time doing elimination. So before going too far here, I want to point out to you something that I do when I am writing my problems down. You'll notice that my z's, I'm putting a bar through, but my number 2's do not. If I didn't put the bar through the z, my penmanship is such that it would be impossible for me to tell the difference between them. I see this happen with students frequently. I would encourage you on these problems to put a bar through your z's so you can tell the difference between a variable and a number. You don't have to do that, but I think it's probably a pretty good idea. Everybody okay with that idea? Okay. All right. So we're going to do this problem by substitution. Let me talk through the idea here, the process that we're about ready to do. Is that a hand or a stretch? Okay, no problem. I'm just checking. So what we're going to do is we're going to pick one of these 3 equations and pick one of the 3 variables from that equation, and we're going to isolate that variable. We'll then take the resulting equation and substitute it back into the other 2. In doing so, we'll end up with two variable equations. We'll simplify those down to make a new two variable system. From that two variable system, we'll pick one equation, one variable to isolate, and then plug that into the other one, giving us a one variable equation that we can solve for, and then substitute back through to get our solution. So there's really going to be three substitutions that we have to do here. Okay? So the first step is to pick an equation and pick a variable from that equation that we'd want to isolate. There's no wrong choice here, but there is choices that can make your life much easier. So if we look at this, which variable and which equation would be a good choice to make? I would not choose which equation, but which equation? I would not, so we're not doing elimination right now, we're doing substitution. That's okay. So we're trying to isolate a variable. I would not pick y from any of these equations, because getting y by itself would involve dividing by 4, which is going to create a fraction in all of these equations. And if I don't have to deal with the fraction, I prefer not to. So let's look again. Joe? Yeah, from either A or B, right? Yeah. If I isolate z from either A or B, because the coefficient on z is 1, I don't have to do any division getting it by itself. And so it's impossible for me to have created a fraction. That's what I would choose to do. For the sake of argument, let's use equation A. It doesn't really matter. So to get the z by itself, I'm going to subtract 4x from both sides, subtract 4y from both sides, and that'll get the z all by itself. Is everybody okay with my decision making here? Again, there would be nothing wrong with isolating a different variable from a different equation. The goal is just to try to avoid having to deal with the fractions, right? And again, if you get fractions, sometimes that's unavoidable. But if it is avoidable, let's avoid them, right? It just slows everything down. It's not that they're impossible to deal with, but it takes more time. It gets more tedious. I have better things to do than grind through a bunch of fractions in my math homework if I don't have to do it. You know what I mean, guys? Okay. So what I'm going to do then is I'm going to take this value for z and I'm going to plug it into the other two equations that we haven't done anything with. I'll plug it into B and I'll plug it into C. So B is then 2x minus 4y plus, but instead of z, I'm going to write negative 4x minus 4y plus 24. And then I still have the equal 0. Similarly, for equation C, I have 5x minus 4y minus 5, but instead of times z, I'm going to put minus 4x minus 4y plus 24, and that's still equal to 12. So what I did is I took this value for z and plugged it into these equations B and C. Is everybody okay with what I've done? All right. So now what I'm going to do is I'm going to simplify down these two equations. So if I look at the first one, you'll notice that there's no coefficient in front of that parenthesis, right? So that parenthesis doesn't really need to be there, so I can just ignore it and combine my like terms. So 2x and negative 4x gives me negative 2x. Negative 4y and another negative 4y gives me negative 8y. And then I still have that plus 24 equal to 0. And I'm just going to go ahead and move that 24 over to the other side. So subtracting 24 from both sides gives me that. And I'm going to refer to equation D. everybody okay with what I did there? I'm going to do the same thing for my other equation now. So here I notice I do have a coefficient in front of the parenthesis. So the first thing I need to do is distribute that -5 through. So -5 times -4 gives me +20. -5 times -4 gives me +20. -5 times 24 gives me -120. And then I still have that equals 12 at the end. Now I'll combine my like terms. So 5x and 20x is 25x. -4y and +20 gives me +16y. I still have that -120 and still have equals 12. And then lastly, I'm just going to add that I'm going to add 120 to both sides. And we're going to call that equation E. So the result of those first two substitutions is I have now two variable equations, right? Those are the equations D and the equation E. I'm going to take those two together, and those are going to form a new two-variable system. And now this is just like the homework problems from last time. So we're still going to use substitution here to do the solving. So which equation and which variable would we want to isolate? Again, there's a good choice here. There's not a wrong choice, but there's a good choice. And what variable from the first one? Good. So if I get x by itself from equation D, when I divide by -2, I'm not going to be left with any fractions, right? And that's my goal when I'm choosing my variable to isolate. Is there a variable I can choose to isolate that will not result in any fractions? So that's what we'll do. So we're going to add 8y to both sides and then divide by -2. Oops. And then I'm going to go ahead and take that value for x and substitute it into E. Oh my goodness gracious, guys. Look what I did. That is supposed to be a y. Great googly moogly. Okay. So now I've substituted the value for, or my equation for x into equation E. Now I'm going to simplify things down. So I'll distribute that 25 through. 25 times -4 is -100. 25 times 12 is 300. If I combine the -100y with the +16y, that gives me -84y. And if I subtract 300 from both sides, 132 minus 300 is -168. 25 times 12. Joe? So 120 plus 12 is, that's okay. Again, like checking on things is no problem. If we whether I make a copy mistake or you make a copy mistake, it's important that we figure those things out before we go too much further. So I don't have any problem interrupting and double checking things. Okay? So we're back here. We have negative 84y is equal to negative 168. If we divide both sides by negative 84, we get y equals 2. Yes, sir. Of course. Everybody's okay to there. Okay. So I'm going to take that answer for y, and I'm going to plug it back up into this spot. But in place of y, I'm going to put the 2. So 2 times negative 4 gives me negative 8. And negative 8 plus 12 is 4. Okay. So far, so good. Now I have 2 parts to my answer. To find the third part, I'm going to take each of these 2 answers and plug them in back here. Oops, that's a 2. When I do that, I get negative 16 minus 8 plus 24, which when I add those up, it gives me 0. So my solution then is 4, 2, 0. Always written in alphabetical order, so X, then Y, then Z. Regardless of what the names of your variables are, we'll write those variable answers in alphabetical order. So if the variables were A, B, C, you'd write the answer to A, then the answer to B, then the answer to C. Or if they were L, M, N, you'd write them in the order L, then M, then N. Right? Regardless of what the variable names are. Alphabetical order. Okay, so that's what substitution looks like. Really the same process as 2 variables, but we had to do kind of more substitutions there, right? Let's do this now as an elimination problem. So we'll do the exact same problem, we'll just do it using elimination, and that'll give you guys a good feel for which one you think is going to be easier for you. I would not require you to do one versus the other. Okay with that? So you're free to choose whichever one feels the easiest to you. But I think it's important that we at least see what it looks like and I don't just tell you this is the easiest one. So I'm just going to recopy that same problem. So we'll call this equation A, B, and C. I just ran out of space on the left, so I just put the letters on the right. I hope nobody's freaked out by that. Okay, so let's talk about the idea here and how this elimination is going to work. So what I'm going to do is I'm going to choose one variable to eliminate. To do that, I'm going to take one pair of my equations, add them together in such a way so that that variable eliminates. Then I'll choose a different pair of two equations, add those together in such a way that that same variable eliminates. I now have two variable equations that'll form my new system where I do another elimination there, where I pick a variable that's remaining to eliminate, add the two equations together in such a way that that variable eliminates, leaving me with one variable equation that I can solve for directly. Okay? So the first thing I'm going to do is I'm going to choose a variable to eliminate here. Now there is no wrong choice in choosing the variable to eliminate. It does not matter, but you can make your life easier if you choose depending on your choice. So if I look at the variables involved here, which variable appears to be the easiest to eliminate? Should be kind of an obvious choice. The y's. That's what I would choose as well, because I noticed that if I add equation A with equation B, I'll have a positive 4y and a negative 4y. Those will cancel out. Similarly, if I add equation A and equation C, I'll have a positive 4y and a negative 4y. The y's will cancel out. So I don't have to multiply any of the equations by anything in order to cancel out the variable. That's the best case scenario. That makes life a little bit easier. Not that it's hard to multiply the equation by a number, but if we don't have to, let's not, right? It's just one more, one more set of work to do that we don't have, that we can avoid by choosing, right? Okay. I'm not going to recopy equations A and B and then equations A and C here to do the addition because they're just sitting right there. I'm just going to copy it or write down the answer. So 4x plus 2x gives me 6x. 4y plus negative 4y gives me 0. 1z plus 1z gives me 2z. And 0 plus 24 gives me 24. Now if I add a and c together, 4x plus 5x gives me 9x. 4y plus negative 4y gives me 0. 1z plus 5z gives me negative 4z. And 24 plus 12 gives me 36. Is everybody okay there? Yes, Stefan. Well, if we add those together, you could, but if you add those together directly, the y's don't cancel out. So you'd have to do b plus negative 1 times c. And that's fine. You can certainly do that, and the y's will cancel out, and it's not a big deal. But you'd have to do that multiplying by a negative 1, where it's just one more step of work that we can cut out by making a different choice. But it's not wrong to do that. You know what I mean? I want to be clear about that. If you had a different idea, like often cases, there's lots of things you can do. I'm just trying to get you guys to notice places where you can save having to do some extra work, right? Do you have to do it that way? No, you don't. You can make the problem longer if that's what's obvious for you to do. That's okay, right? You don't have to be making the same decisions I am. And for me, because I've done this for so long, it's very easy to see ways to make the problem shorter. If that's not easy for you, but you know what to do, just do what you know what to do. You know what I mean? Like, it doesn't have to be the shortest way to do it or the most efficient way to do it. If you see what to do next, just do what to do next. And don't worry about how places to save work right away. I'm just trying to mention that as we go. Does that make sense? Okay. So I'm going to refer to these guys as equation D and equation E. Just as an aside here, I want to point to you how much quicker we got to equation D and E by doing elimination than we did by substitution. Look at all this stuff that we had to do for substitution to get to D and E. Look at what we had to do here. Quite a bit quicker, right? Again, I don't care which method you do, but I personally like elimination because of this step right here, that when we do the eliminations, everything gets shorter, as opposed to substitution, which gets longer before it gets shorter. So here's my new system with D and E. So again, we need to pick a variable to eliminate. Which variable appears to be the easier one to eliminate? X or Z?
X.
Okay, Pedro says X. To eliminate X, we would have to find a number that both 6 and 9 go into. So like 18. So I could multiply the first equation by 3 and the second equation by -2. That would make the coefficients positive 18 and -18, so the x's would cancel out. What would we need to turn, or what coefficient would we need for z's to cancel out? Jack, this is for you. If we wanted to do the z's, I'd want 4, right? Is the number that both 4 and 2 go into. So if I multiply equation D by 2, I can then just add it to E directly. That's what I would have done. It's no problem if you wanted to do the x's, and the x's were what seemed obvious to you. But there you have to multiply both equations. If I'm doing the z's, I only have to multiply one equation. That to me seems a little bit less work. That's what I would do. It's not wrong to do the other one. But again, I'm trying to point out places where we can save some work, because these problems can be very long if you don't, depending on the choices you make. So here I will recopy what I'm going to add together because I've changed one of them. So 2 times D, so I'm going to do 2 times 6x, that'll give me 12x. 2 times 2z, which would give me 4z. And 2 times 24, which gives me 48. And then we didn't do anything to E, so I'll just recopy that one. And then I'll add down. 19 plus 9 is 21. -4 and +4 give me 0. And 48 and 36 give me 84. So then if I divide both sides by 21, I get x equals 4.
Mr. Kulik,
Yes.
for D and E, didn't you use like the equation A to add into both of them?
Yes.
Does that affect anything, or is that like the right way to do it?
So whenever to form equations D and E, you're always going to use one of the two equations to make both of them.
Oh, okay.
Because you're always going to take a pair to make D and then a different pair to pick to make E. But because there's only 3 equations, there's always going to be one equation that's in both pairs. So that'll happen every time. That's okay. It doesn't have to necessarily be equation A that's used in both pairs, but one of the 3 will be used
For
both of them. Yeah.
Gotcha.
Okay. So we have our first part of our answer, right? To find our second part of our answer, we're going to go back and plug in our x into either equation D or equation E. I would pick equation D because the numbers are a little bit smaller, so it's a little less tedious, but not so much so that it really makes much of a difference. But, you know, if I can avoid a little bit of stuff, let's avoid a little bit of stuff, right? So I plug 4 in for x, and I get 24 plus 2x is equal to 24, or sorry, 24 plus 2z is equal to 24. Subtract the 24s from both sides, and then divide by 2, and that gives me that z is equal to 0. Is everybody okay there? And now, just like before, I'm going to take these two answers and plug them back into one of A, B, or C. It doesn't really matter which. For the sake of argument, I'm going to plug them into A. So that's going to give me this. Put it that way. So I'm going to have 4, but instead of x, I'm going to write what x equals, which is 4. And I have plus 4y. And then I have plus, but instead of what z is, I'm going to write what it equals. That should equal 24. So 16 plus 4y is equal to 24. Subtract 16 from both sides. And then if I divide both sides by 4, I get y is equal to 2. So my answer then is 4, 2, 0. Again, we always write them in alphabetical order, so x, then y, then z. Okay. So that's what substitution and elimination look like. You're free to use whichever method you feel you understand better or feels easier for you to use. Personally, I like elimination. It feels like it's less writing, and there feels like there's more places to make the process shorter than substitution. But that's a matter of choice, right? If you understand substitution better, use substitution. It's not a problem. They both work all the time. They both work basically the same way. It's just going to be a matter of which one you feel more comfortable using. Or you could use it interchangeably, right? Like there's no reason you have to do substitution every time or elimination every time. You can switch back and forth between them if you see, you know, a way to make the problem shorter doing one versus the other. Or you can try some of each and decide which one you're better at. Maybe you don't really know which one is going to be easier for you until you try some. So don't feel like you have to even do one the whole time. You can switch back and forth or whatever you want to do. Is that okay? That's what we're gonna stop here for today. We still have 40 minutes or so left of class. What I'm going to do, 30 minutes, that's fine, is I'm going to put the next homework assignment here into our OneNote. And I'm going to give you guys the remaining time in class to just work on this assignment. I think it's really important here, especially considering this process is kind of lengthy, that you have an opportunity to like ask questions if you get confused on something, or check answers if you get to an answer, or talk to your friend to see if they're doing the same process you're doing and what they did here when something happened. I think that's all very important. I want to take some time here in class to give you an opportunity to do that. So this next 30 minutes, we're going to work on that. So I'm going to sync my notebook right now. So if you go and you look in the content library, at the bottom you should see something called Homework 5. You might need to sync your notebook first if you don't see it right away, but I've just synced mine, so if it doesn't show up, you just might need to sync your notebook or sync again even. It's possible you might need to sync more than once depending on how long it takes mine to get up to the cloud. But we'll spend the rest of the class period, the next 30 minutes or so, working on this. If you have questions on things, you can feel free to come and talk to me. If you want to check your answers on things, I have the answers, and I can certainly check those for you and let you know if you've made a mistake or if you haven't. And that's the plan for the rest of today. Obviously, this assignment, this homework 5, will be part of the homework check for Sunday. But this will be the last thing in the homework check for Sunday. So it's these homework 1, 3, and 5. We'll come back and get to 2 and 4, but it felt like this was going to be the better order for me to do this year. Okay with you guys? Okay. So that's it for me then. I'm going to stop the recording.